This lecture is all about kinematics. Now, kinematics is a branch of classical mechanics, and what it does is describe the motion of points, bodies, or groups of bodies in space and over time. We will be talking about forces later, but the kinematic analysis that we're doing in this lecture doesn't require any knowledge about the forces that cause the motion. It's just about the motion itself. And our end goal of a kinematic analysis is to find, for a mechanism, figure out what are the equations that are going to describe the kinematics. And of course, our end goal is to find the kinematic description for the hapkit. So one of the important concepts in kinematics is that of a trajectory, because this is how we describe the motion of a body and how it evolves over time. So you're going to see a lot of plots like this, where you have a plot like position versus time, and you want to know what that's going to look like. And there are a few important things to consider. So one is that you can never go back in time, and so you should never see something loop over itself like that. So another thing that you don't want to see in a plot like this is a big discontinuity in position. So for example, you don't want a position that's going like this and then is suddenly jumping to another position, because then it would have to have instantaneously moved in space. Also, you don't want to obviously have any gaps in time. If you have this and then something picking up later, then the object had no location in space during this time. So that can't be true either. So let me give an example of a very simple trajectory, and there's also an animation of an object moving below that corresponds to the trajectory. So in this trajectory, you have an object moving between a position x1 and another position x2, and it's moving in this single dimension over time. So the blue line on the plot shows a flat area in the beginning. So that means if I start this animation, where the position is going along that horizontal axis, that over time it's not actually moving anywhere. It has zero velocity, it's just staying at x1. But then you can see the position ramps up, and so if I animate that, the block moves from x1 to x2, and you can also see that happening on the position time plot. And then we have another pause where the block just sits there holding at x2, and then it goes back to x1. So you can see obviously that on these trajectories, the plot can go downward, it can slope downwards, and that just means that you have a negative velocity. The object is moving back towards its original position.